Hello guys, welcome to SumoCode. So today we are going to know, is Java pass by value or pass by reference. But before that, we should know when other terms pass by value and pass by reference are used. So these terms are used whenever we are calling a function and passing some parameters to them. So what does pass by value mean? In pass by value, whenever a function is called, the arguments are copied and the function receives a copy of the original value. So whenever you make any changes to the parameters of the function inside that function, its value is not affected outside of the function usually. And what does pass by reference means? Whenever a function is called, the function receives a reference to the original object, not a copy of the original object. So if you make any changes to the parameters in the function, inside the function, then the original value that was passed outside of the function, that value may also get changed. Now, since we are clear with the terms pass by value and pass by reference, let's see what Java is. So Java is always pass by value. Java is never pass by reference. Java is always pass by value. But if you are using Java for some time, you may have noticed that it is not always true. Whenever you pass some variables to a function, sometimes its value gets changed outside of the function, and sometimes it doesn't. So why does this happen? And the reason behind that is the type of the variable that you are passing as an argument to that function. So because of that, Java behaves differently. But under the hood, Java is always pass by value. Java is never pass by reference. You may not be clear what cases I am talking about. So let's look that in the code. So now let's look at this code, what is happening here. So we have created this primitive variable num, which is of type int, and assigned it a value of 10. We pass this to this function, updates its value here to 12, and we have some print statement which prints the value of this num variable inside and outside of this function. So now let's run it and see what is happening. So as you can see, originally the value was 10, then inside the function we updated it to 12, but outside of that function it is not getting updated to 10. So this is good. Java is pass by value, so if we change the variable's value inside the function, it is not reflected outside of the function, so that is good. But wait, let's change the type of the variable and let's see what happens. Here, in this example, we have used a reference type variable, which is of type student class. I will show you my student class. It just have one name variable and nothing else. And we are creating that student object, giving it some name, printing it, passing that object into this function. What it is doing, it is updating the name variable to sumo, printing it out again, and outside of the function we are again printing it out. So now let's run it and see what happens here. Here originally we set it to code, that is true. Then inside the function its value get changed to sumo, that is good. But outside of the function as well, it is getting changed to sumo. So now it is behaving like pass by reference, but you said Java is always pass by value. This is because of the different type of arguments we pass to the function. Now let's look at under the hood why it is happening. So to understand the above cases, we have to first know how the variables are stored inside the Java memory. To start with, in Java, you can create two types of variable. One is the primitive type, another one is the reference types. The primitive type variables are created using the primitive data types that are already given by the Java, such as integer, long, double, float, byte, char. So using all these primitive data types, you can create primitive type variables. Another one is the reference type variables. So in Java, any object that you can create becomes a reference type. So here in this case, consider if I have this student class and I'm creating this object, it becomes a reference type. Similarly, other examples are like of the list you create objects of, or the linked list, hash maps. So all those utilities that you use in Java commonly are also reference types. Also, one more important point is primitive types actually hold the actual value that are stored in them, but reference type variables actually do not store the original value, but they store the reference to the object which is present in the heap memory, because objects are always stored in the heap. So to know it in more detail, let's look at the memory spaces Java has. Java has different memory spaces, but today we are going to just look at the two of the main, which is the heap memory space and another one is the stack space. So two types of memory spaces that we are going to look are heap and the stack. So what does heap memory space stores? All the objects that are created. So whenever there are objects created, they are always stored in the heap space. They are never stored in the stack memory space. Also, all the global GRE environment variables or the utility functions or anything is there, that is also stored in the heap only. Anything global. And in stack memory space, all the local variables that are created are stored in this space. It also includes all the reference type variables that are also created. So those are also stored in the stack only, but they actually hold the references to the objects that are in the heap. So those are also stored. And one more important thing that they store is, so if you are calling one function and it calls another function, so all those call stack, it's the functions, local variables, local state, program counter, all those also are stored in the stack's memory space only. Now let's look at how primitive type variables are stored in the memory. So here, if this is my current line which is going to get executed, int x is equal to 5, what happens inside the memory if this is my memory representation? So what happens inside the stack memory space, at some address, consider 121, a value of 5 would be assigned or stored with the variable x. So this is as simple as it gets. A variable x is stored in the memory with a value of 5 at some address 121. Then how does reference types are stored? This is a bit tricky, so let's look it. So what happens? Consider if this code is going to get executed. Here in the first line we are doing is we are creating an object student and storing it in the variable s. So first this object is going to get created, and this object is going to create it in the heap memory space. So in the heap, at some memory, consider memory address 121, we are storing this student object. So that value is stored in the heap at some memory address 121. Now this left hand side, which is assigning the reference type variable s of type student, we are assigning it the value of this new object that we have created. So and that allocation happens inside our call memory space. So let's assign that. So consider at some one memory location 122, we are assigning a variable s which stores the memory reference, which is nothing but this memory address as its value. It doesn't store the value directly, it stores the memory reference. It points to here. Now in the next line, what happens? We are updating its property, student's property name, to SumoCode. So how that happens is, in the memory, it finds its memory address, which is 122 of the student s variable. Then at 122, it gets its value. It finds that it's in memory reference. So because this is a memory reference, it goes to the heap at 121 memory location, finds its value, and updates its name variable, name property as SumoCode. So this is how primitive types and reference type variables are stored inside the memory in Java. Hope this is clear. So now let's look at our earlier examples, what was happening in them. So first, let's look at our primitive types case. So here in our main function, in the first line, what is happening is one primitive variable original is getting created and it is getting assigned a value of 5. So what happens in our memory is, because it's a primitive type, it is always going to get stored in the stack directly. So in this memory representation of ours, at some memory address, consider 121, we would be creating our original variable and assigning it as a variable of 5, storing it. Now in the next line, calling a function and passing original as a parameter to that function. So now let's go into the function here. Because Java is always pass by value, the original parameter that was passed, we have to copy its value to this new variable num. So here in the memory, again we have to create one more variable num, and at some memory address 122, it is going to get stored with a value which is a copy of original variable, which is 5. Now in the next line inside the function, its value is getting updated to 10. Now we will come out of the function, and here we are going to print the value of original variable, which is still 5. So here you can see that if primitive types are passed as a parameter into a function, then if any changes is done inside the function, they are not reflected outside of the function in the original variable. Now let's look at our second case, which is of reference types. So here again, let's go line by line. So in this first line, we are creating an object. So it is going to get stored in heap. And also we are also assigning the student variable with that object. So what happens is first we have to create this student object in the heap. So let's create it in the heap at some memory address 121. We are going to create that student object, which has a name variable as well. Now in the next step, we have to assign this student the value of the object, which will be stored in the stack, but its value would be the reference of this object, which is in the heap. So let's create it in our memory. So here a student variable is created at some memory location 122, and it will be holding the memory reference of that object, which is at address 121. In the next line, we have to update the name variable of this student object. So here we access student, which is at 122 memory location, gets its value. It is a memory reference, which is 121. So we go to the heap, find that 121 location, get its value, update its name variable as code. Now in the next line, we are passing our object student into the function. Now, because Java is again always pass by value, we have to copy the value of the student object into this obj object. So let's create this obj object at some memory location 123. We have to again copy the value of student object, which is a memory reference. Now inside this function, we have to update the name variable of obj object. So let's access obj, which is at 123 location. Value is a memory reference 121. So we go to the heap to find that memory location, which is currently storing the value as code. So we will update it as sumo. So this gets completed. Now come out of function and print the student value. So student, let's access it. Its value is the memory reference 121. So we access it from the heap, and the student's current value is sumo. So here in the cases of reference types, you can see that because the variables hold the memory references of the original object, so if you change or update the value of some variable of that object, it gets affected outside of the function as well. So to a function, if you pass an object or a reference type and updates its value, then outside of the function, its value will also gets affected. So that's why Java is always pass by value, and in cases of reference types, it looks like it is pass by reference. Hope you understand why Java is always pass by value. If you have any question, please ask me in the comments down below. Please like, share, and subscribe to my channel SumoCode. Thank you. Bye.